A massive concrete structure rises at the edge of a city. It looks finished. It looks solid. But the cost of building is still accumulating inside the walls. The contract was signed with one clear goal. The client wanted a fixed price. The contractor accepted the number. That single agreement set everything else in motion. Fixed price contracts transfer cost risk to the builder. The client pays one number regardless of what happens. This felt like certainty. It was actually a pressure vessel. Public projects in this era were growing in size. Cities were expanding rapidly. The complexity of each project was rising faster than anyone's ability to price it accurately. The contractor submitted the lowest bid to win the work. Winning required being competitive. Being competitive required accepting risk that no one could fully quantify at the time. The contract locked the price before the full scope was understood. Every change after signing became a negotiation. The locked number became a constraint on every decision that followed. In the first months, the contractor built at normal pace. Costs tracked close to the estimate. The project looked like it was working exactly as planned. Then, scope changes arrived. The client requested modification. Each change was individually small, but each one added cost that the fixed price could not absorb. The contractor had two options when costs exceeded the contract ceiling: renegotiate and delay the project, or reduce material quality to preserve the margin. Both carried risk. The contractor chose to substitute materials: thinner steel, lower-grade concrete. These were not invisible decisions. They were calculated ones made inside a shrinking margin. Substitutions like these were not unusual in construction. Equivalent materials were an accepted practice. The problem was not the substitution itself, it was the scale at which it was applied. The inspections were real, but inspections check against specifications. If the specifications allowed tolerance, the substitution passed. The system validated what it was designed to validate. The client's oversight team focused on schedule and budget. Quality tolerance was delegated to the contract. That delegation created a gap between who held the risk and who monitored it. Future videos on this channel examine how similar delegation gaps shaped other large institutional losses. Subscribing ensures those analyses reach you when published. Midway through the project, the contractor's cost model was broken. Revenue was fixed. Costs kept rising. The only lever left was reducing what went into the structure itself. The structure continued to rise. From the outside, it looked identical to specification. The reduction was invisible. It was embedded in connections, joints, and interior layers. This is the core mechanism of fixed-price failure. The cost cannot disappear. It can only be relocated. The contractor moved cost from their margin into the structure's future performance. The project was completed on time. The client accepted delivery. Both parties fulfilled their contractual obligations. The structure was handed over and the contract was formally closed. Once a structure is accepted, the warranty obligation shifts. The contractor's exposure narrows. The client now owns the long-term maintenance risk. The handover moment transfers the cost vector permanently. The structure entered service. It performed as expected in the first years. Loads were within design range. Stress accumulated slowly. Nothing visible on the surface suggested a problem. Structures degrade at different rates depending on material composition. Lower-grade concrete absorbs moisture differently. The degradation curve was slower at first, then non-linear. Maintenance budgets for public infrastructure are set years in advance. They assume average degradation rates. A structure degrading faster than the model predicted would not trigger intervention until inspection. Years after delivery, the first visible surface cracks appeared. An inspection was ordered. The inspector found that subsurface degradation had already advanced well beyond what the surface indicated. The inspection revealed a gap between documented specification and actual construction. The contractor had fulfilled the contract as written. The specification had allowed tolerances the client assumed would not be used. This is the tolerance trap. A contract that permits a range of acceptable values invites that range to be used under pressure. The tolerance was written for exceptional cases. It became the operating standard. The client now faced a structure below optimal specification, but legally compliant. Pursuing legal remedy was costly and uncertain. Remediation was the faster path. Both options were expensive. Remediation of embedded structural components is fundamentally different from surface repair. To fix the interior, you must remove and replace. The cost multiplies with every layer of access required. The remediation cost exceeded the original contract value within the first phase. The structure had to be taken partially out of service. The operational disruption added an indirect cost on top of the direct repair. This is the cost inversion point. The fixed price that once protected the client is now the reference against which the remediation cost is measured. The original savings were smaller than the repair multiplier. The contractor had dissolved or restructured by the time the degradation became visible. There was no entity left to hold accountable. The contract had expired. The liability had expired with it. Liability expiration is a structural feature of fixed-price contracts. The contract closes when the work is accepted. What happens inside the structure after that point belongs entirely to the client. Public clients face a distinct problem here. They cannot simply walk away from failing infrastructure. The structure must function. Remediation is not optional. The cost must be absorbed regardless of source. This is what makes infrastructure the highest stakes environment for fixed-price contracts. The asset cannot be abandoned. Its ongoing cost is a public obligation. Failure is not an exit. It is a transfer. This pattern repeated across dozens of post-war public projects. The fixed-price model spread because it appeared to solve the budget problem. Each new project carried the same unpriced risk forward. The accumulation of deferred structural cost across a public asset portfolio is not visible in any single project. It only becomes visible when multiple structures reach their remediation threshold simultaneously. When the threshold is crossed simultaneously across the portfolio, the public agency faces a funding demand it cannot absorb in a single budget cycle. The cost becomes a fiscal crisis, not an engineering problem. Reforming fixed-price contract structures after widespread adoption is extremely slow. Each active contract represents a legal commitment. The reform can only apply to new contracts. The legacy cost continues accumulating. Some agencies introduced performance bonds as a safeguard. A bond requires the contractor to post collateral against future failure. But bond amounts were set against estimated defect costs, not full structural failure costs. The bond covered defect correction. It did not cover operational disruption, emergency intervention, or the compounding cost of delayed remediation. It addressed the symptom, not the structural gap in the contract model. The deeper structural lesson is about information asymmetry. The contractor knew the material substitutions were made. The client did not. The contract did not require disclosure. Asymmetry was legally protected. Modern procurement frameworks attempt to close the disclosure gap through open book accounting. The contractor must show all cost categories. Transparency is now a contractual condition, not a courtesy. But open book requirements add monitoring cost. They require skilled oversight staff. They slow procurement. Every safeguard that addresses one failure mode introduces friction into the system that carries its own cost. Every contract structure optimizes one dimension of risk at the expense of another. Fixed price reduces budget variance. It increases quality and scope risk. There is no neutral contract design. Every choice is a trade. The decision to use fixed-price contracting was not irrational. It reflected real budget constraints, real accountability pressures, and real political demands for cost certainty. The mechanism was reasonable. The hidden cost was structural. The structure still stands. Remediated sections hold. Others await the next inspection cycle. The original contract number is long settled. The cost of that number is still being paid.